Now that we know how to solve, I guess, problems like, sine of what angle is some value, we're going to actually solve harder equations, but it's going to be pretty much the same idea. Okay, so let's go ahead and solve this one. Solve this angle within 0 to 2 pi. Now, if they say 0 to 2 pi, that's an indication that your angle should be in radian and not degrees. If it says 0 degrees to 360 degrees, then you should be in degrees. Okay, so this is going to be a radian question. All right, 4 cosine theta minus 1 equals cosine theta. So kind of take out your algebra skills. What do you think you should do first? What do you think you should do first? Okay, so you can see that cosine is repeating, so obviously we're going to subtract cosine on both sides. So basically combine like terms. 4 cosine minus 1 cosine is 3 cosine. All right, next, what should we do? We're going to solve for the angle, so we're going to have to try to isolate the angle, right? So we have to get the theta by itself, so we're going to have to add 1 on both sides. And then we're going to divide by 3. All right, so we basically get it into a form we have seen before. 1/3 again is not in, or 1/3 is not in the unit circle, so we're going to have to use the calculator. So theta is equal to inverse cosine of 1/3. All right, so you've already practiced this a lot on the homework, so go ahead and give this a try. Pause the video, come back and check your answer. All right, here are the answers. They don't want all angles, just between 0 to 2 pi, so there are only 2 answers. So where is cosine positive? That's going to be here and here. And so when you use the calculator, it gave you a positive number, so it has to be this one, 1.231. This, by symmetry, has to also be 1.231. And so to find that angle, what you do is you go 2 pi, which is going to be overshooting. So 2 pi and then go backwards. So 2 pi minus 1.231 is going to get you that 5.052. All right, let's have you practice one. 3 sine theta plus 1 equals sine theta. So do it the same way as before. This one, I believe, should be an angle within the unit circle, so you don't want to use the calculator. Go ahead and figure this out. All right, go ahead and check your answer. So first you solve that equation and you get sine theta equals -1/2. And so since sine is negative, it has to be in 3rd and 4th quadrant. And -1/2 is a number, is a value in the unit circle. So if you just kind of think back on it, on your unit circle, the angle that would make sine -1/2 is 7 pi over 6 and 11 pi over 6. All right, let's solve something that's a little bit trickier. This, again, you really need to bring in your Algebra 2 skills that we learned before with factoring and then make it equal to 0, that kind of skills. So looking at this problem, what kind of stands out to you between the first and second term? And you can see that sine is repeating, right? So sine is repeating, what do? Okay, you take it out. So you're going to factor that out. 2 cosine plus 1 equals 0. Now this is a very simple problem of something times something equals 0. That means either the first part is equal to 0 or the second part is equal to 0. So either one. And this is just an easy problem to solve. So this part is cosine theta equals -1/2, and then we solve that. All right, so now let's think about it. Sine of what angle gives me 0? Sine, which is the y direction, of what angle makes it 0. Okay, good. 0 and pi. Okay, because this is 0 to 2 pi, so we want radian answers. All right, next. Cosine of what angle gives you negative 1/2? All right, if you forgot, take out the all students take calculus. Cosine is negative, so it has to be here and here. So which two angles will make it negative 1/2? Which two angles will make cosine? Cosine is the x direction, negative 1/2. That's going to be 2 pi over 3 and 4 pi over 3. So in this question, there are 4 answers. Okay, and what we did was we applied our algebra skills to first make the equation equal to 0. This is kind of what we always have to do, make it equal to 0, and then factor, and then make each factor equal to 0. All right, now let's go ahead and practice. This one's a little bit harder. I'm gonna try to help you get started. So first, you can see that sine is repeating, so definitely take out sine. Now that it's in the factor form, make each part equal to 0. All right, sine theta equal to 0. We solved that before, so you can just look at that yourself. This right-hand side part is a little bit trickier, so we're going to solve it. So cotangent squared is equal to 3. And to solve for theta, we're going to have to take each part out, carefully. So first we have the square that we have to get rid of. So that means we're going to square root. So cotangent is square root 3. That's incorrect. When we square root something, there is always plus minus. All right. Now we don't know anything about cotangent, and well, we don't really know anything about tangent really. So we're going to just solve it the same way. Cotangent means cosine over sine. So what angle will make cosine over sine plus or minus square root 3? And same thing as what we had learned before, it has to be square root 3 over 2 over 1/2, right? This is the only way to get to square root 3. And since they want plus minus, and that basically gives us all the possible options. If both of them are negative, then the ratio has to be positive. If one of them is negative, the other is positive, it's going to give us the negative option. So essentially, it's all of the four angles that has this ratio. All right, cotangent is related to tangent. And so if we look at all students take calculus, we basically want tangent to be positive and negative. So that's going to be all 4 angles. All right, in either case, cosine is the longer one and sine is the shorter one. Okay, so maybe I should try to draw it more similar to what it looks like. Cosine is the longer one, sine is the shorter one. So that means x is longer than y. X is longer than y, then it has to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. These 4 angles. Okay, and then here we have 2 more angles from sine theta equals 0. So that gives us 6 answers. And I solved this problem for you instead of letting you practice. But this is a little tricky. All right, give this next one a try. This one should be much easier. Try this one and then come back and check your answer. All right, the correct answer in this one is 0. Okay, so for cosine, there is only one place, one angle that would give cosine 1, which is at 0 degrees or 0 radian. All right, give this last one a try. Find the x-intercept. Find the x-intercept. So it's really not a hard problem. It's just another way of asking the same question. Remember, x-intercept means what? X-intercept is when y is 0. So make y 0 and solve. So same thing as before. And yeah, this is a kind of a interesting problem or fun problem. So go ahead and give it a try and check your answer later. All right, so hopefully you got these 6 answers. If not, I'm going to kind of show you really quickly how to solve it. So you can see that sine squared is repeating, so we're going to take sine squared out of everything. So 2 sine squared left here and just 1 here. All right, so we're now in factor form. Make each part equal to 0. All right, sine squared equals 0. You can square root it, but it's really unnecessary. Square root of 0 is still 0, and then you can solve that. All right, this part, you would add 1 over, and then divide by 2. You get that. Square root that. Remember, when you square root something, you have plus minus. So square root of 1 over square root 2. Now, you might be saying, what is square root of 1 over 2? You're right. It is something we have not seen before. So let's simplify it. And remember, you can rationalize the denominator. Square root of 1 is just 1. Square root 2 is square root 2. Now, to rationalize, we multiply top and bottom by whatever needed to get the denominator out of there. So this is going to be plus minus square root 2 over 2. Square root 2 over 2, we know what that is. It's going to be one of the 45-degree angles, and therefore this is the answer.